Hello and welcome back to the Inside Java podcast, the podcast about everything Java, brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog, and this episode of Input Output, our new show where we talk to people outside of OpenJDK, is a short conversation with Joe Di Pol that we live streamed from JavaOne in March 2026. Joe is lead principal platform software engineer at Oracle, where he works on Helidon, an open source Java framework for writing microservices. Helidon is interesting because it is still small and nimble, and it makes use of that by aggressively adopting cutting-edge Java features like fully embracing virtual threads. You will hear during the conversation how that goes beyond just supporting them. Joe and I also talk about Helidon Support for AI and a few new features in version 4.4, as well as the plans to make Helidon an OpenJDK project. Enjoy the episode. But let's talk about the technology first. So maybe we'll go into a little bit of what Helidon's ethos is and then what the recent releases did there.
Okay, yeah. A couple things that make Helidon a little different from the other microservices framework out there is we support two kind of programming styles, two APIs. One is Helidon SE, which is a fluent imperative style programming. It's our API, it's our foundational API for Helidon. And then we have Helidon MP, which is our microprofile support. Mm-hmm. And that's based on the microprofile specifications, which are based on Jakarta EE core profile. So for developers that are familiar with EE APIs like JAX-RS or that want a CDI runtime, we have our microprofile support. So we give choice to pick from those APIs. We have a long-standing kind of tenet of the project to be highly aligned with the JDK. So right from the start, we've always tried to adopt JDK features rapidly. Mm-hmm. And our best example is with Helidon 4. We really embraced virtual threads.
Okay. So what does it mean to embrace them? Because many frameworks do support them. What do you think you would say is the difference between supporting and embracing?
Yes. So in the planning for Helidon 4, we had a couple decisions to make. We knew virtual threads were becoming final, or at the very end, it was close call when they would be final in Java 21, but we knew that was coming. So we knew we had to at least support them, which a lot of frameworks do. They all do. But we made the big decision, kind of bet the farm on rewriting our web server to be based on virtual threads.
Okay. That might be the first bigger one, maybe?
At the time, it was certainly, I think, the first significant web server.
I have a good friend in my Discord who had, I think it's called Micro HTTP, which is a virtual thread-based server. And he built that very, very early, but that was not meant as a production grade server, like the one that you built.
Absolutely. I don't want to discount any other implementations out there. We were one of the first for sure. And it was a big decision for us. In Helidon 3 and earlier, we were Netty based.
Yep.
And so that's a big leap for us to rewrite the web server. But
so we briefly, let's just briefly talk about the difference there. So something like Netty would have a very intricate process of being able to accept incoming connections, but then parcel that out to regular platform threads. And there's like a shake-off, there's like a queue that stuff goes in and stuff goes out and all that stuff. Yeah. And with virtual threads, you're basically saying we do none of that. It's just one request, one virtual thread. We trust the VM to do its thing, right?
Yes. Okay. So Netty kind of being an asynchronous event-based server, which is what you kind of had to be performant in the Java world. You have to follow the asynchronous programming model. And so in Helidon 3, the thread that is executing your endpoint handler is a Netty worker thread, and you must not block that thread, right? That's rule number one. And therefore, you had to do asynchronous programming. So with Helidon 3, our SE API was asynchronous, and you had to deal with completable futures and do asynchronous programming. With virtual threads now, with the web server, the web server implementation got to be very simple. And we have from the socket up, we say, with virtual threads. So the virtual thread, so when a connection comes in, we allocate a virtual thread to read the request off the socket.
Yeah.
And that virtual thread is the one that executes your handler. And that virtual thread is dedicated to that request.
Yeah.
So you can block on it without impacting anything else. And all the platform thread scheduling, we just leave up to the JVM. And it has been spectacular. In one of our presentations, Ryan said, no drama, right?
Yeah.
It's just highly scalable, high throughput, no drama. Latencies are very predictable. It's just been terrific. So we kind of bet the farm on doing that, and it's paid off, we think.
Yeah, I can immediately see like two advantages, or two additional advantages of what you just described. One of them is any improvement that will happen to virtual threads under the hood, to scheduling there. That is just now that Loom has delivered that. This is just now the regular maintenance / performance work that happens in JDK all the time. So you will automatically benefit from that. You don't have to do anything for that. So that's, I guess, is a big plus. You rid yourself of all of that complexity that you would otherwise have to maintain. And the last one is that I just earlier talked about structured concurrency, which if you use structured concurrency to farm out concurrent tasks, you get this thread relationship between these threads that are spawned there. And that means that in any thread that I am in my application where I have set a breakpoint or where I have to like dump the thread, do a thread dump, I can trace back, this is the child thread of this structured task scope, and this is what the other threads are doing. And I can really now go, as you say, like all the way up or down, however you want to point it, to the WebSocket. Yeah. Like the entire scope, like all of that, including the web framework, is all discoverable straightforwardly, because you don't have to use like some tracing ID or some other IDs to associate threads with one another.
Right.
You can that's your thread tree basically, and you can go all the way up if you need to. And people do have to do it less than navigating a stack, so just a single thread stack. But like clicking on a different stack element in your IDE is so commonplace for debugging. I think once this is established, it will be the same amount of course we do it that way. Anything else would be crazy. But of course I can just go to a sibling thread, go to the parent thread, go all the way up to the WebSocket, go all the way down to my database request. Once the navigation is quite there, it's not quite there yet in IDEs, which I think is mainly down to the JDK not exposing this information yet, but I'm not sure. So I don't want to point fingers in IDEs when I say the debuggers don't support that yet. I think there's like a give and take on both sides. Okay, should we talk a little bit about Helidon and AI? Because that's also something that Helidon is supporting.
Yes.
Or supporting beyond just, how every web framework or every library can be used with any other,
Right. So, by the way, we just had our 4.4 release.
Yeah.
And we had some improvements with that. Supporting Java 26 is an obvious part of that. On the AI front, in Helidon, we support LangChain for J, so we have integration with that. And what that integration provides is some ease of use. So instead of needing to use the fluent builders of LangChain for J directly, you can drive all that through configuration. So you can define your providers, your models, all through configuration. And then our LangChain for J integration then uses that in order to instantiate the LangChain for J objects. We also do some adaptation of LangChain for J APIs so that they become more blocking, because we like blocking APIs.
Yeah.
So while with native LangChain for J, you may need to use asynchronous APIs when retrieving messages back, we convert those to Java streams. So you can just use the stream API and not worry about asynchronous programming. So in 4.4, we updated to the latest version of the LangChain for J spec. Release. Of course, there's probably a new one this week. They release very often. And we added agentic support. So LangChain for J supports agentic APIs. And so now with Helidon 4.4, you can write your AI agents using Helidon. So that's LangChain for J. We also support MCP, MCP protocol. So we have Helidon MCP, so that you can write your MCP servers using Helidon as well.
Okay.
Yeah.
And the interesting thing here is that usually in these kinds of streams, I always say like I'm mainly focusing on OpenJDK. That's kind of like the thing that I want to do the most. And I do occasionally branch out, so you'll probably be here even without that. But there was a cool announcement at the keynote that is gonna it's going to combine these two strands. So do you want to repeat it here, or?
Sure. So we've announced the intent to move Helidon to the OpenJDK.
Yeah.
So our open source project to move that under the OpenJDK umbrella.
Yeah, nice.
As well as we intend to adopt the JDK tip and tail release model. So that's coming up, and we'll see that.
Yeah, so the one thing that's very important to just point out there, this is not about making Helidon part of the JDK.
Correct.
OpenJDK as a community surely is best known for developing the JDK project, the JDK codebase, but it does already have other projects. By no means, for example, JExtract is its own project in there, and so that does not mean that it's going to be part of the JDK. I don't think there are any plans for that probably. Right. So Helidon is just going to be governed by the same structure, and it's also going to gather then hopefully a wider open source contributors, and as you said, the release cadence will be a similar one. You're also planning on the 6 months and like releasing at the same time. Is that the idea? So yes. First of all, we should also say the intent is the important part here. OpenJDK is its own community. Nobody can just push things through. So we'll see how that plans out.
That's
the details,
right.
All the details are TBD. But is your intent to go for the same 6 months or release on the same kind of date?
Right. The intent is to adopt a JDK release cadence.
Yeah.
And also push the minimum JDK requirement forward.
Interesting.
As we go we do tip and tail.
Yeah. So, it really means you're really adopting things early.
Yes.
Now the question is, do you plan on having a version that uses preview features? Probably not.
It gets complicated. So it gets complicated. It's hard. If you have a feature which can be modular and standalone, and in general, Helidon is highly modular, then we can do things like that. If you're using Java 26, then you can add this module, which only works with Java 26.
Yeah.
But for a lot of the interesting features, they're not like that. Like structured concurrency, that would pervade, it's pervasive.
Yeah, exactly. And the issue is with that is that the way that previews work intentionally are written in a way that the version you compile with is the version you have to run with.
That's right.
So if you switch from, let's say I'm using in the future JDK 29, and I'm using the Helidon that is released with that version. And if it would use a preview feature, I could not run those Helidon jars on Java 30.
That's right.
And that's a severe limitation. It's intentionally written into the preview mechanism. And that's why I get a large project like that can probably not adopt that. I know that I have my own projects who are constantly doing that, but that's fine. They have a user base of one, so I think I can get away with that. Okay. Yes. That's about it, right? Is anything else you want to share with us? Maybe something that's in 4.4? Is there something more that we missed? Or
okay. Just a couple of quick things. So in 4.4, we continue to add additional annotations. So what we're adding kind of as preview features to Helidon is annotations on top of our Helidon SE API. So instead of using the Fluent builders, you can actually use annotations. And the way we implement this is these annotations are processed at compile time and generate, or before compile time, and generate source code.
Okay.
So our annotations actually generate source code. We don't do any bytecode malarkey or runtime stuff. It's all very straightforward.
Yeah.
So we're continuing to flesh that out in 4.4 as well.
Thank you, Joe, for being here and for giving us these details. And I wish you good luck on the trek into OpenJDK.
Thank you very much. Very happy to be here.